Now, most important part, what is the determinant? So the determinant, a good term I like to use is the catalyst. The determinant can be many things in math, but the one thing that's really important is that it's a catalyst. It's used to make and create different useful things that we need for calculating special quantities. So for example here, the first thing we need to know is how to find the determinant for our matrix. So here's our matrix A here. We want to find the determinant. So this is the way you might see it. You'll either see it as this, the determinant of A, or they'll say this. Looks like absolute value signs, but it's not. It just means determinant of matrix A. And so to find the determinant, what we do is we take A times D, so A times D minus, and then B times C. B times C. That would be our determinant of A. Now why? Why do we want to do this? Well, we need the determinant to find inverses. So for example, if I wanted to find the inverse of A, how would I do that? Well, first I need the determinant, because to find the inverse, this is the formula. It's 1 over the determinant of A times, and then we're going to do something special to the elements in A. So if you see up here we have A, B, C, D. Well, when we're finding the inverse, we switch A and D. So D goes here, A goes here. And then we make B and C negative. And so this is scalar multiplication, remember? So we take this fraction here, take this fraction and multiply it by this new matrix that we made from matrix A, and it will give us our A inverse. And one thing to note here is your determinant cannot equal 0. So cannot equal 0, because if it does, then you will have a 0 in the denominator here, and that'll be undefined. So it'll be undefined. All right, so one cool property of our inverse is, just like we said in the previous slide, if you multiply our inverse, we should get the identity. Same thing, it works the same way with our matrices. So if I multiply this, the inverse of A times A itself, we should get the identity matrix, this. But one thing we have to remember is, in order to get the inverse, to find this, our matrix must be a square matrix, or this won't work. What I mean by square matrix is, you can see right here we have A as a 2 by 2. So we need 2 by 2, 3 by 3, 4 by 4. It has to have the same number of rows, and columns. And you'll only ever have to do a 2 by 2 by hand. If it's bigger than 2 by 2, you're going to use the calculator, and I will show you how to do that. So if you look here, I have my calculator, and I already have a 3 by 3 matrix in here. So that is a square matrix. So to find the inverse, what I'll do is, well, first of all, if I want to find the determinant, I can just go quit and second matrix. Determinant is number 1, math, and then matrix, then put in matrix A. And then that will be my determinant, 13,000. If I wanted to find my inverse, I can just say, oh look, go back to matrix A, and then this little x negative 1, that means inverse. Put that there. That's my A inverse. If I wanted to prove that it's the inverse, I can say, okay, this times matrix A should give me the identity. And you see here, I get the identity. See, I get a diagonal row of 1s.